Hello, everybody. So, when we talked about the arithmetic sequences, we found the common difference. But not every sequence is going to be delineated by simply adding or subtracting something from it. We could also multiply or divide, and this is where we get into geometric sequences. A sequence is geometric if there is a number r, called the common ratio, such that a sub n plus 1 over a sub n, so a greater term over a lesser term as far as in sequence, is equal to r for any integer n is greater than or equal to 1. And what I wrote over here to the side is to show you what this is actually saying. I take a higher term in the sequence, so a sub 2, and divide it by the next subsequently lowest term, a sub 1. So for our example, identify the common ratio r. So I'm given a sequence. Now, some of these you could look at and say, and try to find D, the common difference, and you wouldn't be able to find one. Like this one, it alternates. So I could say, okay, well, you add 1 to it. To go from a negative 1 to 1, I add 1. Whenever I look at the next term, if I add it 1, then I should be at 2. So that is a common ratio. I'm doing something here that isn't simply adding or subtracting. So my first term is going to be a sub 1, right? And in this sequence, it's a negative 1. My common ratio is going to be a sub 2 divided by a sub 1. A sub 2 divided by a sub 1. My common ratio is a negative 1. R equals a negative 1. So a negative 1 times a negative 1 is 1. 1 times a negative 1 is a negative 1. A negative 1 times a negative 1 is 1. And that shows how my sequence goes by R. So pause the video and then identify a sub 1 and a sub 2 and then find R. Alright, so what I'm going to do is I know that R equals a sub 2 divided by a sub 1. A sub 2, 4, 2, R equals 2 for this one. Meaning 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. I could not get that by just adding or subtracting, how each term changes in the sequence. For my next one, R equals a sub 2 divided by a sub 1. Well, a sub 2 is a negative 4 thirds, and a sub 1 is 2 thirds, which simply turns into, I multiply by the reciprocal. I have 4 thirds times 3 halves, and I end up with a negative 2. So R equals a negative 2. And just like with our common differences, I do not have to use a sub 1 and a sub 2. As long as they are consecutive terms and I take the higher term in sequence and put it over the lower term in sequence. So I could do, for instance, I could do a sub 4 over a sub 3, or a sub 8 over a sub 7. Okay, so let's take a look and expand upon what we just did with talking about our common ratio. Nth term of a geometric sequence. The nth term of a geometric sequence is given by a sub n equals a sub 1 times r to the n minus 1 for any integer n that is greater than or equal to 1. And remember, r, and we're just calling it a sub 2 over a sub 1. So find the ninth term. And here is our sequence, 2 and 2 radical 3 and 6 and so forth. So I identify a sub 1 and a sub 2 and I find my r. A sub 1 is 2 and a sub 2 is 2 radical 3. So a sub 2 divided by a sub 1, and that gives me my r. R is a radical 3. So find the ninth term. That's where I get a sub 9. So in this right here, n equals 9. So a sub 9 equals a sub 2, or a sub 1, which is 2, right, times r, right, radical 3, to the n minus 1. It's 9 minus 1. So what I actually have here is a sub 9, the ninth term in this sequence, geometric sequence, equals 2 times radical 3 to the 8th power. And after doing the math, I end up with my ninth term being 162. So pause the video, and I would like for you to work this example here. All right. Let us identify the formula. I always like writing that out first. A sub n equals a sub 1 times r to the n minus 1. And let's see, I'll write it over here. So I'm going to have a sub 2 divided by a sub 1. That's what r equals. So let's identify what we have. I know that I'm finding the 10th term, so n equals 10, and I know a sub 1 equals 64, and a sub 2 equals a negative 32, and I have everything that I need. I will take this and I will plug the information in there. So a sub 10 equals 64, that's my a sub 1, times r. What is r? Well, let's calculate r. A negative 32 divided by 64. That's a negative 1/2. My r is a negative 1/2. So I end up with 64 times a negative 1/2, and this will be 10 minus 1. See, 10 minus 1, so 10 minus 1. So what I end up with, here's, after I get everything pieced together, that's going to be 64 times the negative 1/2 to the 9th power. And then what I do is I just take this and I take 2 to the 9th and 1 to the 9th. So we'll do that, because this will be easier this way with this type of problem, because then I'll simplify my numerator, so to speak, 64, and 2 to the 9th, 16, 32, 60, 5, 12, and then 64. I got to get the calculator out for this one. Will 64 just go into 512? That's what I'll see. 512 divided by 64, and it does 8 times. So this becomes 1 and this becomes 8. So what I'm left with is a negative 1/8. And that is what the 10th term is in this sequence. And we could, since we already had 4, we could turn around and calculate the 5th one. And then we could calculate the 6th one and the 7th one. This is much less work that's involved to be able to get our answer. Alright guys, please critically think and structure your work. Stay motivated, watch those publishers' videos, and good luck on your remaining homework problems.